Welcome to The Explainer. Today, we're digging into a patent that could seriously change how we interact with our own brains. We're talking about a design for a neuro enhancement system that isn't just about boosting performance, it's built from the ground up with a completely revolutionary approach to safety.
So, this is the real million-dollar question, isn't it? This is the core problem this patent is trying to solve. It's all about moving past a simple, kind of brute force enhancement and getting to a truly intelligent system that understands that the risks, well, they're just as critical as the rewards.
All right, here's how we're going to break it all down. We'll kick things off with the core problem, then take a look at why current tech just doesn't quite cut it, and then we'll get into the good stuff, this new architecture, from its central safety features to its incredible precision targeting, and of course, the governance that's built right in.
Okay, so to really get why this new system is such a big deal, we first have to understand the old way of doing things.
You know, for a long time, most systems were what's called open loop. Think of it like a one-way street. A preset stimulation gets applied, and that's it, no matter how the brain is actually responding. Now, the big leap forward was closed-loop systems, which create a kind of two-way conversation. But, and this is a big but, this patent argues that when you're dealing with something as delicate and complex as memory, just having simple feedback, well, it isn't nearly enough.
So, if even these smart, adaptive closed-loop systems aren't the whole answer, what's missing? What are the specific dangers that they just aren't equipped to handle?
And right here, this gets to the absolute core of the problem. You see, enhancing neuroplasticity, that's the brain's amazing ability to rewire itself, isn't automatically a good thing. It's really a double-edged sword. If you open that gate for learning at the wrong moment, you can accidentally reinforce all the wrong things, like strengthening negative emotions or even creating dangerous neural instability.
Okay, so to manage these huge risks, this design doesn't just tweak the existing loop. No, it adds a fundamentally new component, a whole new layer of intelligence with one and only one job: safety.
So here's a look at how this new architecture actually works. It all starts with a readout of biological data. An estimator then uses that data to figure out the brain's current learning state. Then a controller calculates the ideal stimulation. But, and this right here is the crucial innovation, before a single jolt of stimulation is delivered, it has to get the green light from the safety supervisor. This simple change transforms it from a feedback loop into a supervised loop. It's a total game changer.
A good way to think about the safety supervisor is as a dedicated risk manager that's sitting on top of the performance-focused controller. Its only job is to enforce the safety rules, and it has the ultimate veto power to make sure every single intervention is not just effective, but fundamentally safe.
But look, this system's intelligence isn't just about preventing bad things from happening. It's also about being incredibly precise in its actions, and it uses two core principles for targeting.
Yeah, this whole thing is built around the idea of a plasticity gate. So instead of trying to force the brain to learn, the system just waits. It intelligently identifies the exact moments when the brain is naturally most receptive, and then it gently opens a window to enhance that natural process.
The first principle is something called temporal selectivity, basically the when. The system is designed to act only within these very specific windows of time. During the initial encoding of a memory, later on during its consolidation while we sleep, or in that brief, fleeting window that opens when we recall it. And what's really crucial here is that outside of these moments, it stays completely inactive.
The second principle is spatial selectivity, the where. The system operates on an incredibly precise map of the brain, from large circuits all the way down to individual dendritic spines. And by using a predefined set of targets, it stops the stimulation from leaking into other areas and causing all kinds of unintended side effects.
So we have this really powerful safety supervisor. But how does it actually spot these complex risks in real time to make its decisions? How does it know when to step in?
Well, the supervisor does this by constantly watching a dashboard of what are called key performance indicators, or KPIs. Each of the big risks has its own set of measurable signals. For example, if it sees abnormal brain waves that point to overexcitation, boom, immediate stop. Meanwhile, other behavioral metrics might catch maladaptive learning, which tells the system to tone down or change the stimulation. This isn't just guesswork, it's data-driven safety.
And believe it or not, the system gets even smarter than that. The supervisor doesn't just react when a metric crosses some hard red line. No, it also watches for negative trends, which allows it to step in before a problem gets out of hand. If the system's own confidence in its readings drops, it automatically defaults to a safe mode. So it can act not just when something is wrong, but when it predicts something is about to go wrong.
And finally, with technology this powerful,
you can't just bolt on the ethics at the end. I mean, that's a recipe for disaster. This patent makes the case that accountability and control have to be engineered into the system right from the very start.
So there are two components here that are absolutely critical. First, there's an unchangeable audit log that records everything the system does, and more importantly, why. Every input, every decision, every safety judgment. And second, there's a clearly defined stop authority, making sure a human is always in control. This level of transparency is essential for any kind of ethical, real-world use.
Now, this stop authority is layered for maximum safety. The system can stop itself automatically, a clinician or a researcher can step in and stop it, but, and this is the most important part, the patent guarantees that the user themselves always has the final say and can stop the system at any time, which provides an absolutely essential ethical safeguard.
So when you put it all together, what we have here is way more than just a clever device. It's really a comprehensive blueprint for the future of neuro enhancement. It's a design philosophy where precision, safety, and accountability aren't just nice features to have, they are the absolute foundation of the whole thing.
You know, this technology brings us to a really fascinating and complex frontier. It forces us to ask not just what's technically possible, but what's fundamentally responsible. And what it suggests is that the answer lies in engineering our ethical frameworks with the exact same rigor we apply to our circuits and our code.